I need to start by differentiating my substitution, but I don't like the square root, so I'm not going to differentiate the way it's written there. I'm going to rearrange to get rid of the square root first. So I'm going to subtract the 2 from both sides. Then I'm going to square both sides. I'm going to subtract the 1. And divide both sides by 2 to make x the subject. Just swap that round so the x is on the left-hand side. And now I'm going to differentiate to get dx by du. So we'll times by the 2 here, so the 1/2 times the 2 will just be 1. We'll take 1 away from the power, so the 2 will just become 1. And when I differentiate the minus 1/2, it's just going to be 0. Then make dx the subject, so I'm going to times both sides by du, and I get u minus 2 du. So the dx is going to get replaced with the u minus 2 du. Next, let's focus on these limits. So we've got when u is 4, sorry, when x is 4 rather. So if I substitute that into my substitution, so u is equal to 2 plus the square root of 2 times 4 plus 1, which is 9. Square root of 5 is 9. Square root of 9 is 3. 2 plus 3 is 5. So when x is 4, u is 5. What about when x is 0? Let's do the lower limit. So u would be equal to 2 plus the square root of 2 times 0 plus 1, which is just 2 plus 1, which is 3. So my lower limit when x is 0 is 3. Right. So we have got the integral from 3 to 5 of 1 over, now this whole term here, well, we know that is just u. That was our substitution in the first place. And the dx we worked out as being u minus 2 du. So I'm going to write that as a single fraction. The 1 times the u minus 2 is u minus 2. So this is just turned into that. I'm going to split that integral into, or split that division in 2. Because we've got the u divided by u is just 1. And then we've got the minus 2 over u. Each of these will integrate easily. The 1 will integrate to be u. The 2 over u will integrate to be 2 ln u. And now substituting in the limits, we'll put 5 in first. Then we'll substitute the 3 in. So we've got 5 minus 2 ln 5 minus 3 plus 2 ln 3. Be careful with those double negatives. The 5 minus the 3 is 2. And I'm just going to rewrite these logarithms. So I'm going to rewrite it so I've got the positive term at the front. And then the negative term after that, just to help me to use the laws of logarithms a bit more easily. The ln 3 minus ln 5 is ln 3 over 5. And we're done. Question 30. Determine the integral of sin x cos x. Well, I noticed that sin x cos x is very similar to the identity for the sine double angle formula. We know sine 2x is equal to 2 sin x cos x. Therefore, I know that I can replace sin x cos x with 1/2 sine 2x. Which is going to make this integral easier now, because I know that sine is going to integrate to be minus cos. But by the reverse chain rule, I also need to divide by 2. So if I divide 1/2 by 2, I get 1/4.